Hello there, this is Grizzly Maximus and I'll be showing you how to create your very own 2D dynamic lighting system here in GameMaker Studio 2. So we're going to be trying to create something that looks like this, except a lot simpler. We're not going to be doing the soft shadows, the bloom effect, and the wall edges, but maybe in a later tutorial we will. And by the way, the best thing about this is that this light can go up to 5,000 lights before it starts dipping 60 frames per second. So right now we're at 4,000 lights, now 5,000 lights, and that's only the time when it starts dipping below 50 frames per second. So in order to create this, we are going to be creating three objects: object setup, another object called object wall, and another object called object light. Now we're going to be creating a fourth object. This one's technically the same object as object light, but we're going to call this moving light. Okay, moving light will have a parent which is light, and we're done. So I can exit moving light here, we can exit light, and for the wall we are just going to be adding its own sprite, and we're going to be coloring it to 16 by 16. Apply that, edit image, go to the sky here, color is blue, and we're done. We're done with the wall. And the last thing we need to do is object setup and a bunch of shaders. Yes, have I mentioned we are going to be using shaders here, so if you don't understand how shaders work, please bear with me. I can't explain how shaders work in this video because it's going to take really long if I do that. So we're going to be setting the room size to 320 by 180. You don't have to do this one. This is just the way I like setting things up. Enable viewports, go to viewport, make it visible, make this 320 by 180. Then we say 120 by 720, that's the width. 1280 by 720, that makes sure that we're going to be displaying the windows at 720p. Now, in our instance, we're going to be changing the grid to 16 by 16. Then we are going to be adding some walls here. We just add whatever bunch of walls we want to add. So we can start stretching these walls, these little bunches of walls here. There we go. Now we have these walls here. We are going to be adding the moving light here, and then we're going to be creating a new instance layer. Move this instance layer lower than the original instance layer, and in this instance layer we're going to be adding our object setup. Just drop it anywhere you want, doesn't really matter. So if we run this game, we would see that the game looks like this. Very simple. Now the object light is on the mouse, we just don't see it. Okay, remember, object, actually I didn't do it yet. I'm going too fast, I forgot to do it. Anyways, in object step, we want the moving light to be on the mouse. The way to do that, you just say x is equal to x mouse x, and y is equal to mouse y, and that's it. We're good to go. Now, even though we did that, we can't see the moving light because we don't have a sprite for the moving light. So how do we make the sprite for moving light? We don't. We are going to be using shaders to be making the light, and we're going to be doing that in the draw function of the object setup. Why object setup and not object light? Well, because it's easier to do stuff here in object light where everything is nice and orderly. All we have to do is just say with object light. My typing sucks. There we go. And we say draw rectangle at 0, 0, 320 by 180 by 0. Now that essentially creates a white rectangle behind the walls, like so. A white rectangle behind the walls, completely filling up the whole entire room because we set it up from 0, 0, 330 by 180. That's the room size. So why are we drawing a rectangle? Well, this rectangle will be the canvas for our light. So in order for us to do that, we're going to be using the shader to be drawing the light onto that rectangle. So we're going to call this shader light. Okay, now we go back here and we're going to say here shader set shade light and shader reset. There we go. Now going back to the object light, the shader light. So this is the vertex shader and this is the fragment shader. We're going to be removing all the unnecessary stuff. So we remove this line, we remove this whole entire thing here because all we need is the in position. We don't need these varying vectors, and so we don't need these varying vectors here inside the main function. Remove this. So all we need are these, because to make the light, all we need is the position, which is essentially the corners of the rectangle. Okay, now we remove this guy here. We don't need these varying vectors, and I like keeping my braces up here because it's, smaller looking. And then we are not going to be sampling anything from the text coordinate and multiplying with the color. Instead, we are going to just make it vec4. This is the RGB and A values. Now we just want to make the RGB the vec3, we're going to set this to 1, and then we set this to 1. Now, this is going to be equals to STR, the strength of the light. So remember, in the light source, the position of the light source, that will be where it's brightest. As it goes further away from the light source, it gets dimmer. So essentially, we need two things in our light shader. We need the position of the light, and we need the position of the pixel that we are currently working on in the fragment shader. Well, first of all, let's just set the float str to, let's just set it to some value so then we don't get any errors. So let's try to get the position of the pixel that we're working on in the fragment shader. And in order for us to know that, we need to go back here to the vertex shader, and we're going to be getting this in position. So we're going to be making a varying vector, a varying vec2, and we're going to call this pos. We're going to be transferring this information to the fragment shader. So we're going to say pos is going to be equals to in position dot xy. So we get the xy of the in position and transfer it to pos. This pos will now transfer to the fragment shader. So we copy that and we paste it here. The fragment shader now has the positions. This is the pixel position of the GL frag color. Now we also need to have the other position, and for us to get that, we need to have uniform vec2 upos. Now this upos is the position of the light source. I call it upos because it's uniform. Let's fix that. There we go. Now, in order for us to have a uniform vec2, what we're going to do is that we're going to say shader, we're in the crate of the object setup, shader get uniform. Okay, we need to do this. This is technical stuff. So we say shader light uniform name, we're going to call this upos. This quotation marks upos, that is the name of the thing in the shader. Now we're going to be calling this also upos. Now this upos is for the object setup. We can call it whatever you want. It doesn't have to be the same name as this guy here. I just name it upos and then I don't get confused. Anyways, so here we say shader set uniform f, and we say this is going to be upos, and the value should be x and y. So this xy is the light position, but hey, wait, this upos should be other that upos. Or what I like doing, you can do other that upos, that will work, but what I like to do is that I like making this guy a local variable. So var underscore upos is equal to upos. I like doing this because working with local variables is easier to the computer. So this guy passes the information to the shader of the position of the light. Now that we have the position of the light, now we want to get the vector distance. So we say vec this is equal to pos minus upos. This is why I like using shaders. You can do vector math. So that thing essentially negates both the x and y of pos and upos together. Now that we got the positions of the two, we're going to get the strength. So the strength is not 1. The strength will be the distance, the inverse of the distance. But this is not the distance we want. We don't want the vector distance. We want the scalar distance, which is the Pythagorean theorem. So square root of pos dot this dot x times this dot x plus this dot y times this dot y. So if we are going to run this, we have an error because we need to have that to be a floating value. There we go. So we now have a little point light where our mouse is. Now that light source was pretty small. So how do we increase that light source? Well, we can do this thing, and we're going to be adding this constant float zz, and let's set it to 10 first for now. And then we're going to say zz times zz minus zz. Put this inside the parentheses here, so then it gets 1 divided by this whole entire thing. And this thing should increase the light source. If you're wondering what the hell I'm doing, I'll show it to you in decimal. So let's say we have the square root of x squared, okay? As we increase our x, the distance gets further and further away, which makes sense. But this thing is linear. Now, think about it this way. As it reaches this 0 thing, this is where that tiny little point light is. We want to be increasing this little point here. How do we do that? Well, we can essentially just do this thing called z-squared. We add a slider, and notice how this thing here is now curved. So since it's curved, it's more blunt. A bigger surface is now closer to the 0. But notice how as I increase the z, this value here starts getting further and further away from 0. We don't want that. So we say minus z, and now it's now stuck at 0 regardless of what I do. as long as it's not negative. So if the z is positive, which it'll always be, you can see how it's just getting more bent. And so the more bent it is, the more blunt it is, and the closer, bigger range is closer to 0. And that's essentially what we did here. So if we change this to 32, we have made the light source even larger. And it looks nice, it looks smooth. This is essentially how to make your lighting systems. Many people do something else, but this is the actual mathematical equation, more or less, of light. Because light actually decreases inversely to the distance. Now that we have this thing here, now we want to be creating the shadows. How do we create the shadows? So we first print this thing and then we make the shadows using vertex buffers. Okay, so here we go, vertex buffer, another big topic. If you don't know how to use this in GameMaker Studio, consider this a tutorial, a very fast tutorial. But what we want to do is that we want to make a vertex format. Before we can make a vertex buffer, we need to make a vertex format. Now, in this vertex format, we say vertex format begin, and then we say vertex format add position 3D. Now, you're wondering why we're using 3D? Well, that's because we're going to be using the Z value for something else, a flag. I'll explain that a little bit later on. Now, we're going to say VF is going to be equal to vertex format end, okay? What this guy does is that we store all this information to this VF. Normally, we have the position, we have the normal, and we have the color for our vertex format. But in this case, we only have the position in 3D. We don't need the others. That's because shadows are always going to be black, so we don't have a variable color, and we're not even getting any texture. So this is all we need. So now that we have created the vertex format, now we can create the vertex buffer. We call this VB, vertex create buffer. Now we go to the step event, and then here in the step event, we are going to say vertex begin. Now in the vertex begin, we put in the vertex buffer and we put in the vertex format. And then we say vertex end. So that marks the end of the vertex buffer. And so anything here done in between this begin and end, we're going to be adding some vertices in these areas here. Okay. Now, how do we do that? So we're going to go to with object wall. And then we're going to be starting to put some stuff here. Now, let me try to draw what we're going to do here. So think about it. We have this wall here, and then we have a light source here. Now, our shadow will be based on this angle. So we draw the shadow here, and we draw this. Now, we're going to be creating, these are the vertices, and we're going to be, this is like one triangle. So this is the shadow that we want to be creating. If we have another light here, let's draw it red. If you have another light here, notice how it has a different shadow. However, these walls here are the same. So what we're going to do is that we're going to be setting this vertices, we're going to be repositioning here temporarily. So this guy is going to be x1, y1. This is going to be x2, y2. In the shader, we want to be moving this guy back there. So how do we know that this is the vertex buffer that we're going to be transferring? Well, that's where the z coordinate comes along. So these guys here will have a z value equals to 1, whereas this guy here has z value equals to 0. But these guys will also have x1, y1. This guy's going to be x2, y2. x1, y1 is actually this position here. But when we say z is equal to 1, the shader is going to say, oh, okay, we're going to be repositioning this vertex from here. We're going to be repositioning it to this guy here. Now, first of all, we want to be constructing a quad. How do we construct this quad? Well, we're going to be making a function to construct this quad using the new GameMaker Studio 2.3. So we're going to make a function quad. You don't have to make a new script for this. We just can put it here, a local function, and we're going to be putting a variables vb x1, y1, x2, and y2. Everything will make sense later on. Now, we're going to say vertex position 3D. And here we are going to do this 3 times. 1, 2, 3. These 3 will be these triangle positions. Okay, so we're going to be getting this guy first. So this one's going to be x1, y1 with z equal to 0. We set in the vertex buffer, and then we say this is going to be x1, y1 at 0. Let's just remove this. For the next one, we're going to be doing this guy here. It's also x1, y1, but this time z is equal to 1. Okay, so we set this to 1. We do it one more time here. This time it's going to be focusing on this guy here, which is x2, y2 at 0. Change this x2, y2 at 0. Now, for the next triangle, we could see that this diagonal here is the same. So we can just copy these two and you can paste it here. It's the same thing, just one more vertex position. So we say x2, y2, but this time we're going to be setting it to 1 because it's here. And essentially we are done creating a quad. Now you might be wondering, why did we draw this here and not here in this object wall? Well, that's because for each wall, a wall essentially, this is object wall. This is not a wall. An object wall it's a box, right? Some boxes are actually longer, some boxes are like this. Each of these object walls have 4 walls. We have the west wall, north wall, south wall. But to make calculations easier, we can actually just get the diagonals instead. We're going to be casting the shadows using these diagonals as our walls. It actually works, trust me. So this position here is x, y, and this one's going to be x plus w, and this is going to be y plus h. The sprite width and the sprite height. So we're just going to say quad. This is why we made the function. It makes things way easier. Then we set it to VB. Now before we do anything, let's set a variable VB is equal to VB. We do this, so then we have a local variable that can bypass the object wall. Now here we say that x1, y1 going to be xy, x and y, simple as that. Now x to y2 is going to be x plus w and y plus h. So that's x plus, that's going to be sprite width, and y plus sprite height. Now we want to get this guy here as well. So this is actually x plus w y, and this one is x y plus h. Okay, so just copy this guy here, paste it here, and essentially what we do is that we just get this guy here and just move this to this side here. So this is now x plus sprite width, that's u, and then this guy here is this guy here. Okay, now we are going to be drawing this on here. So to draw the shadow, we will say vertex submit. So we submit VB. Remember, it's supposed to be var VB is equal to VB, so then we can pass it through the object lights. So we say VB and then say PR triangle list. Now you want to be wondering, what's a PR triangle list? Well, a PR triangle list is this guy here. So 3 points create a triangle, another next 3 points create another triangle, next 3 points create another triangle. That's essentially what we did here. Remember here, 3 points make a triangle, 3 points make a triangle. The last value here is the texture. We've set this to -1, meaning no texture. Now if we run this script, we would see an error that says here, vertex format not supported, it needs the position and the color, blah blah blah. Now the reason why it's doing that is because we are using the regular shader here. We need to be using another shader, and we're going to call this shader shadow. Now here in the shader shadow, again, we're going to be removing this. Here's where the error comes along. It's because we are asking for the texture coordinate and the color, and there's none. So we remove this. We also remove these guys here. We remove these guys here. Move this guys here. And we remove this entire thing here. Bye-bye. You see, we're even shortening the codes here. That's how amazing this thing, how easy this thing is to do. So we set this to vec4, and we say, let's just set this to vec3 for now. Set this to 0, because RGB is 0, meaning it's black. And then the alpha is going to be 1. And if we run this, it's going to still give us an error because we forgot to set the shader. Whoopsies. Let's go back to the object setup. And here we do shader set. But instead of shader, we say shader shadow. And then the shader reset, we can actually put the shader reset outside here. So if we run this, we would see that there is no error that comes out. But where are the shadows? Well, there's no shadow because remember, we just drew our shadows at x1, y1, and then we drew it at x2, y2, and drew it back again at x1, y1. Like, it's just a line. There's no triangle. So in order for us to show you that triangle, or the quad, because we have 2 triangles that create a quad, a quadrilateral, we are going to the shadow, and we're going to go to here to this part here, and we're going to be asking ourselves if in position dot z is greater than 0. Don't forget the dot. Anyways, so in position dot z is greater than 0, we're going to be changing the positions here. Now, to demonstrate this, we can't change the in positions directly, so we have to make a vec2 position, and we're going to be calling this in position dot xy. Does this look familiar? Because it is. And we're going to say pause is now going to be plus equals to, let's say 64. This is just a random value just for testing purposes. And then we set this to position X and position Y. We run this and you see we have these crazy shadows that are just, I don't understand. Okay, that's because we have repositioned, if the Z, if it's greater than 0, which is 1, then we reposition the position to plus 64. Now, this is not what we want to do. In order for us to have different shadows, we need to pass the information of the light source position, just like we did last time with the light. So all we need to do is just copy this code, uniform vector, from the light, and we go to the shadow and we do it here. Now take note that we're doing this in the vertex shader. We're not doing it in the fragment shader. We can actually leave this fragment shader alone for now. Anyways, so we set uniform vector to upos here in the vertex shader, and then we go to the object setup. We have to do exactly everything the same thing, except that we set this guy here to shadow, and we set this upos. No, this upos is the same, but here the variable has to be a different name. So we set it. Yeah, let's call it upos2. Now, here in the draw, we are going to be copying this guy here, but after the shader set shadow, we're going to say upos2, which is not yet a variable. So we say variable upos2 is equal to upos2 without the underscore. There we go. Now that the shadow has the U position, the position of the light source, we can get the distance again, the vector distance, like we did last time. Vector distance is equal to pos minus U pos. And then we are going to be relocating the position. Actually, do this here. We are going to be repositioning the position. If Z is greater than 0, we're going to be adding this distance here. Okay? Now that's not enough, because if you just add that distance, it's not going to reposition that far. So what we're going to be doing is that we're going to be making this a unit vector first for uniformity. If we get the vector distance divided by the scalar distance, the magnitude, which is going to be, again, this dot x times this dot x plus this dot y times this dot y. This is why you should not skip your trigonometry lessons, because trigonometry is very important in game development. So this is now your unit vector, and we are going to be multiplying this by, let's say, 100,000. Why 100,000? Well, this is a very large value. This is because this is a unit vector. Unit vectors are very small, but if you multiply it by 1,000, that makes that unit vector really large. Now remember that this unit vector is the same slope as your distance. So think about it this way, okay? Let's just draw it. Let me show you what I just did there, if you didn't understand exactly what I was doing. So we have here, this is your point, this is your wall, okay? So let's say this is the vertex that we're trying to relocate somewhere else here, okay? But we don't know where that thing is. We first get the distance, so we get the y, and we get the x distance here, and then we get the unit vector of these guys here. So we divide these guys by this distance here. So right now this is the distance vector. Now we get the unit vector. So the unit vector is this guy, x, y, where this distance here is 1. And then we multiply this vector by 10,000. So we said 10,000. So this vector just goes, you know, very far away. We're going to say this guy, add this vector here. So that unit vector multiplied by 1,000 is, this position is now going to be added with that. So this guy here is going to be boom, it's going to go all the way to infinity. So you don't see where that vertex point is. We want the vertex point, the end vertex point, to be outside of the screen. So that's why we're multiplying it by a very super ridiculously large number. So if we run this script, we should see, lo and behold, shadows. Wow, amazing. Amazing. Very nice. Now, there is still one thing you need to do, and that is multiple lights. Now, making multiple lights can get a little bit tricky, but don't worry, I'm going to be showing you exactly how to do it the non-tricky way. So, we'll go to object setup, and let's make the function that creates more light. So, we're going to be making more lights by left-clicking the mouse. So, we say if mouse button, check button press, MB left. We say instance create depth at mouse X, mouse Y at depth, and object's gonna be object light. So if that thing is getting a little bit too long, there we go. So we just create a new light using that function. It's for testing purposes. So we create a new light here, And notice how my mouse is not moving now with the light source. And we create another one and now it's moving with the light source. And then if I click again, nothing happens. Makes no sense. Now, there's a reason why it's doing that. That's because the light is actually overlapping the other light. So we don't see the previous light. The reason why it's doing that is because we are using blend mode normal. What we want to do is that we want to set the blend mode, to BM add. That way, we add the blend mode, we add two lights together. So two lights make a brighter light, okay? Because that's how lights work, it's additive. And then don't forget to set the blend mode to normal after you do the lights. So here we go. So if you add another light, notice how it adds up. Okay, so you keep on adding more lights in the same position, it just makes a brighter light. And notice how when I move this light, it just like combines like some bubble. Now, the problem about this system that we have right now is that if I were to draw a shadow here, cast a shadow over those lights, the shadow destroys those lights. Now, shadows shouldn't be doing that. Shadows shouldn't block lights. The light's supposed to be over the shadows. Okay, so something's wrong with their implementation, and that's because our shadow is here. So when we draw the light, and then the shadow goes over the light. Now we can move this here, but we still have another problem because this shadow here will still block the previous light. So doing that didn't solve the problem. However, putting the thing here is one step forward because we're going to be doing some optimization, which I call the blocking method. What most people do is the cutout method. Now, the cutout method requires you to be drawing these lights on a different surface. So essentially we draw a light on the separate surface, and then we cut out the shadows from that surface, and then we move those lights back to the main surface. The reason why we have to do it in the separate surface is so that those shadows do not destroy the previous lights. But is it possible to do it all in one surface, on the main surface? And the answer is yes, it is possible. And that's what I'm going to be showing. It's called the blocking method or the speed spray paint method. Because what happens in speed spray painting, watch my other video which explains it, is that the spray painters basically block portions of the canvas and then they paint over it. Now, because those parts are being blocked, you don't paint those parts. However, anything that was below the stuff being blocked does not get affected. Unlike the cutting out method, when we draw the shadow here and we essentially remove everything behind that thing. We don't want to remove anything behind the shadow. We just want to block the light from being casted on that area. So how do we do that? Well, we're going to be using GPU Z set Z test enable and GPU set Z right enable. Okay, let me set this to 1, meaning true. Now what this does is that this thing turns on 3D. So we're now going to be using the Z coordinate in order for us to determine the depth. So this allows us to determine the depth. The Z test enable and Z right enable. You have to turn on both. What happens is that we are now going to be setting the shadow to be closer to the screen. The way we do that is by decreasing the Z. Decreasing Z value makes it goes closer to the screen. We draw the shadow and then we draw the light. Now this light is going to be blocked by the shadow because this shadow is over this light. Now the thing is that this shadow is still going to be blocking the lights previous here because we're going to be making this draw black. But if we actually make those shadows transparent, which is what we're going to be doing now, if we set the shadow here, instead of this, we just set this to 0, meaning it's a completely transparent shadow. Now, let's say we set this to 0 and we set this guy here to 0. So now they have the same Z position. If we were to run this, we would see that it's not being affected, okay? All the lights, there is no shadow. That's because it's in the same layer, and what happens is that the shadow is drawn first before the light. If we were to change the shadow and we set this to, let's say the shadow's now -0.5, you would see that there's now shadow being casted because now the shadow is closer to the screen. Even though it's transparent, it will still not draw underneath that transparent shadow. Now it's still being affected because this next light is still drawn on the same layer as this light, and all the shadows are being drawn in this layer. What we want to do is that we want to have light shadow, light, shadow, light, shadow, light, shadow, light, shadow, where the shadow, the corresponding shadow of the light is in front of its light. So in order for us to do that, we need to add another variable called var z, and this z is going to be transferred to the shader as a shader uniform. So we're going to be doing this crazy stuff again. So we say uniform float, just a float, uniform float uz, and we're going to be setting it here, and we're going to be copying this guy here, we're going to be copying this code, we're going to be putting it here in the shadow, and then we're going to be putting it uz minus 0.5. We're going to keep this minus 0.5, so then for every corresponding shadow, it's going to be in front of its light. Now, we're going to do this again. This is a little bit weird. I don't really understand why we have to do this, but we have to do it. So we say uz light, here uz, and then we do this again, but instead of light, we change the shadow, and then this one's going to be uz2. Now we copy this guy here, but instead of upos2, we say uz2, and then instead of xy, we set this to z here, and then we do this exact same thing, put it here, but instead of uz2, we say uzz. Yeah, we have to create this variable here, var uz is equals to u, var uz2 is equals to uz2 without the thingamabob, and there we go. So we have these variables here set up, everything looks good, and we run the script and an error happens. Why? Oh, right. I'm so stupid. We set this to 0. We set the z value here to 0, and then we say z minus minus. That way, we draw the first set, and then we say minus minus, so the next set will be over the next shadow, and then we draw the next shadow here, and we draw, and that should work. This should work. Okay, so we have a light source, and then we can put lots of light, and if we go behind the wall, we do not block the light. So we can put lights here, we can put lights there, we can put lights everywhere, and guess what? It works like a charm. Very nice indeed. Now, let's test this out and see how many frames per second we're going to be getting. So, here in the draw function, let's actually go to draw GUI, and we just say draw text. We set it at 0, 0, let's set it at 15 FPS. One more variable that we need to add, and this one's going to be at 30. We're going to say this is going to be your instance number, object light. Now, we want to increase the rate of how we're drawing this. So here, we're just going to say repeat 100. And yeah, we're going to repeat this process here. Nice. Now, another thing I'm going to do is to have a better understanding of what's going on. We say show debug overlay. This is, we're already done with the setup. We just want to show how efficient this thing is. So now we have this debug overlay here. We could see that we're running at very high frames. So there we go. We added just a ton of lights there. Boom, boom, boom. 300 lights. We're still at 60 frames per second. More. 1,000 lights. And we start to lag. Why are we lagging? Well, the reason why we are lagging is, check this out. Okay, so we're back, and now we have here, I turn on my Riva tuner so we could see what's happening here. Notice how the GPU is at 12%, and as we keep on adding lots of lights here, notice that the GPU is increasing immensely. Now it's at 98%. Now it's starting to complain. Take note, I'm using a RTX 2070, so yeah, if you add 1,000 lights at this rate, it's gonna start lagging. Now the reason why it's doing this, the reason why is because our light is high definition. How do we have less definition lights? For us to have low definition lights, since we set our room size to 320 by 180, we can at the create surface resize, application surface 320 180, and then GUI display maximize, there, GPU display set maximize, and now we see the light is now a little bit pixelated. That's the problem about doing that. But if we were to add lots of lights, let's turn on River Tuner again, we see that the GPU is not complaining anymore. It's like 90%. We can add 1,000 lights and it's still at 22%. We add 2,000 lights, and that's at 33%. And we keep on doing that, and 3,000, it's on 41%. We add lots of lights here, 5,000 lights, and our GPU is not no more complaining. So the reason why we're now experiencing a little bit of lag is because it's CPU lag, not GPU lag. And that's basically it. So we have just created a very simple 2D dynamic lighting system. There we go. Okay, let's actually reduce this to 1 again. It's not. Now, do you need 5,000 lights? Definitely not. See, look, even though we add like 100 lights here, we really could illuminate this whole entire room just with 100 lights. So yeah, we don't need 1,000 lights. That's not necessary. There we go, that's already 100 lights, and it's filling up the room, and we're still at 1,000 FPS. So you don't have to worry your lighting system lagging the game. And it's very simple to implement, as you can see. Not too much lines of code, a little bit advanced, but this is actually pretty small. And we just have 2 shaders, which are very simple. Look at that. Everything could be seen in just one screen. So anyways, that's it for now for this tutorial. I might be making another tutorial which will be focusing on the soft shadows, and another tutorial which will be focusing on the bloom and the light edges. Also, in my next tutorial, I'll be showing you how to implement this with your tile set, because right now this is not, we don't just want to add lights like this. We want to be doing something like I showed you earlier, which is this thing. You want to make something that looks like this, okay? Where it's just not illuminating, it just looks awesome. And then we can have different colored lights, different sizes of lights, and yeah. So that's it for now. Thank you very much for listening to this tutorial. Please like and subscribe if you haven't already, and thank you very much, and goodbye. Have a nice day.